SciCuriousID presents. Throw a ball, push a car, or watch a planet move, nothing ever stops instantly. But why? What invisible law keeps things in motion, resisting every effort to stop them? The answer is one of the most fundamental principles in physics, a rule so universal it shapes the motion of everything in the universe.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Our story begins with Galileo in the 1600s. He noticed that once an object starts moving, it tends to keep moving unless something slows it down. At the time, most people believed motion required constant effort. Galileo realized the opposite. Motion is natural, and stopping is what needs a force. Then came Isaac Newton, who turned Galileo's insight into a law, his first law of motion, or the law of inertia. It states, an object in motion stays in motion unless acted upon by an external force. That means everything that moves from a skateboard to a planet will keep going forever unless something interferes. When you roll a ball across the floor, it slows down not because motion fades away, but because forces like friction and air resistance push against it. These opposing forces convert the ball's kinetic energy, the energy of motion, into heat and sound. If there were no friction, no air, and no resistance at all, that ball would never stop. In fact, that's exactly what happens in space, where satellites orbit Earth indefinitely, moving through near-perfect vacuum. Friction is the hidden culprit that robs objects of motion. On a microscopic level, even the smoothest surfaces are rough. As they slide past each other, their atomic peaks collide and snap, converting motion into heat. That's why brakes heat up, tires wear down, and meteorites burn as they fall through the atmosphere. The difference between Earth and space is resistance. On Earth, air and surfaces constantly drain motion. In space, there's almost none, so motion continues freely. That's why astronauts drift endlessly when they push off, and why spacecraft need thrusters to slow down. Fun fact: car brakes don't actually stop you, they convert your car's motion into heat through friction. At highway speeds, those brakes can reach over 500 degrees Celsius. When an ice skater spins faster by pulling in their arms, that's another physics law at play: conservation of angular momentum. The skater doesn't gain energy, they simply redistribute it, trading a wider motion for a faster spin. The same rule keeps planets spinning and orbiting for billions of years. Even gravity doesn't stop motion, it just changes its direction. Planets move endlessly in curved paths, balancing inertia and attraction. The universe prefers motion to stillness. So why don't moving objects stop instantly? Because motion isn't something to be undone, it's energy, and energy never disappears. It only changes form. From the friction that warms your hands to the drag that slows a plane, every bit of motion transforms, never vanishes, just shifts into another kind of energy. From Galileo's ramps to orbiting planets, motion reveals a simple truth: the universe doesn't like to stop. Everything keeps moving until something, friction, drag, or force, says otherwise. That's why moving objects don't stop instantly. Curious for more? Subscribe and stay curious with SciCuriousID.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.